first of all, myself, before you got on the horn here, I was telling Andrew that, I was born in San Antonio, grew up in Austin, spent most of my years in Texas, both my kids born there. So I'm from there, have pretty good relationships with the Department of Agriculture. We work together and other things. I have a company that's also headquartered in Austin, Texas, called AM Technical Solutions, or AMTS.com. And so this company, we do engineering and design, as well as construction management, clean room build. And then we have a division, we have multiple divisions, but we have a division called certification and performance testing, and we have a QA/QC division. And the reason I say this is because I want you to understand that we're not just a company that is selling air purifiers. We're an organization that understands all aspects of buildings and the HVAC in buildings and the entire air handling system in buildings. And so when we talk about airflow in rooms, we talk about all aspects of it, not just the effluent from a purifier. So, you mentioned a moment ago about, some schools or some people may want to replace HVAC systems and things like that. And, that would be the first thing that I would tell everybody is stop, just stop before you do anything with your HVAC systems, because at the end of the day, the solutions, the solution, there's no, depends on the HVAC system and the buildings, the schools themselves, right? Some schools that we deal with up in the Northeast, they don't even have air conditioning systems in them, right? They have radiant heat and other things in the wintertime. But so anyway, we've also done more particle counting, let's just say, we call it trace gas analysis, but measurement of components and stuff in the air, or what we'll typically use is nitrogen, let's say. But we've done more aerosol particle counting than anybody in the world, I can assure you of that, right? So we understand very well particle behavior, as well as particle entrapment. Our customers consist of all the big names in semiconductor and pharmaceutical, or what we call life science, biopharm, right? So we design, build, certify clean rooms, process utilities, and work with all the contractors. So when you're working with us, you can be assured that you're working with a very competent organization with respect to HVAC and indoor air quality. Now then, when we start talking about the schools and getting, a guy asked me today what Airbox's objective was, and really it's getting people, school kids, teachers, and workers back to work, back to school, back to life, right? Back to life. So, there's, we can have a short-sighted perspective of things, or we can have a more, I think, productive long-term perspective. But at the end of the day, indoor air quality, or let me just say HVAC systems like ASHE standards, needed to evolve. And so what we talk about today is pathogen hardened. So we do certain things within a school and their HVAC systems to pathogen harden that facility. And why that works just fine for COVID, because COVID happens to be the current outbreak, right? So what happens when we have the next outbreak, or the next even pandemic, which we will, right? We will have outbreaks, and because I can tell you now, everybody, the media and everybody understands it, right? It used to be everybody was very familiar with the flu. You catch the flu, yeah. We do that every year all day long, So, but now people, the media, everybody's going to be looking for outbreaks, and so we will have future outbreaks, future pandemics, and the longer term solution is to harden the schools so that when those things occur, we don't have to, well, what are we going to do? Are we going to keep the kids home, or are we going to let them continue to go to school? No, we're going to let them continue to go to school because we've pathogen hardened the school, right? So anyway, there's the the solution, the general solution to that is to install HEPA filtration and air return. Well, the first step is to make sure the HVAC system is well balanced, right? And the second is to install HEPA filtration, well, to provide HEPA filtration in the rooms. The third is to put HEPA filtration in the return air, and then to start monitoring CO2, right? So we monitor CO2 in the classroom. Why? Because CO2 is a great proxy for respiratory aerosols, because that's it. We're trying to control respiratory aerosols, whether they're laden with a pathogen or not. We have to control the respiratory aerosols. So that's what we do. We monitor CO2. CO2 levels get to be 1,000. We alert CO2 levels in a classroom. CO2 levels get to be 2,000. We evacuate, right? Why did the CO2 levels increase? Well, primarily it's going to be two reasons. One, there's too many kids in the classroom. Maybe two teachers decide they want to combine their classroom, or there's a problem with the HVAC system. So, you know, the plan, and that's the other thing. You know, we've all been given, you know, EPA, CDC, federal, you know, all kind of guidelines. You know, here's what you got to do. But nobody has given us a plan. Give us a detailed, comprehensive plan on what we need to do at our school so that we can safely get the kids and the teachers back to school and make sure that they're good. And so these things that I just spoke of, that's basically what we need to do to all the schools on a long-term basis, right? We start now because we get federally funded money to go ahead and start this process. Again, at the end of the day, we have pathogen hardened schools, so they're not subject or prone to future outbreaks and future. One of the things, though, here's a very important thing when we talk about putting air purifiers in the room. I mean, we can go to Costco and buy an air purifier for $400, right, and put it in the room. Well, it's not going to do any good because primarily, you know, it probably doesn't have a certified HEPA or anything, but also the flow rate coming out of that thing is going to be so low, and the associated velocity is going to be so low, it's going to have zero impact on the airflow dynamics in the room. And we have to impact the airflow dynamics in the room, right? So our primary interest is the breathing zone. That breathing zone, that's, you know, we don't care how many particles are on the floor. We care about the particles that are in the breathing zone. Those are the respiratory aerosol particles, right? And so what we want to create in the classrooms or in any room where people are is we want vertical currents. We don't want horizontal currents. We want vertical currents, and we want to scrub the entire room, not just one part of the room. So basically, the indoor air quality, especially when it comes to respiratory aerosol and the breathing zone, you got to look at the efficiency of a unit, whatever that is, the efficiency of a unit to what's the removal efficiency of the unit, and then what is the impact of that unit on the airflow dynamics in the room. And so when you look at our units, if you measure the velocity coming out of a peak, for example, it'll be in excess of 600 feet per minute, right? So that unit pumps out 24,000 cubic foot an hour. We use a technology called computational fluid dynamics, or CFD, to model airflows in rooms, say like in a classroom. And so we know what type of impact that we're having on the breathing zone in that room because we model it with very, very sophisticated software. So when we propose a solution, it's an effective solution, right? And again, I'm thinking long term, we need to consider future outbreaks, that sort of thing. So, you know, so basically the particle testing, aerosol, I mean, that's basically what we call them, aerosol particle testing, analysis. We've done a ton of them. Like I said, we've done more of that than anybody in the world, right? The one thing that's happened now because of COVID is we're not, historically we've been interested only in particles. We don't care what the composition of the particles are. We just want to remove all particles regardless of composition, right? And that's what we do. If you look at an Intel clean room, that's what we do, right? I mean, we have class 0.1 clean rooms at Intel or Samsung. So now then with the pandemic, we're thinking, oh, well, everybody, EPA and CDC and FDA and everybody said, okay, well, what about the ability to entrap pathogens? So basically a lot of the new testing that we've done is what we call bioaerosol testing, whereby we take a unit, we take an 800 cubic foot bioaerosol chamber, we put a unit in there, we flood the chamber with a pathogen. We can't use COVID, so we'll use a representative virus that will flood it with, say, 1 billion plaque forming units of that virus, and then we see how long it takes to reduce the amount of virus in that 800 cubic foot room by 99.99%, or what FDA calls 4 log reduction, right? So all of our products, you can be assured that all of our products will give you a 4 log reduction. I think it's important to understand how that test is performed, because somebody that says, hey, we can give you a 4 log reduction, well, did you do it in a real life environment? Did you do it in a glove box? Or excuse me, did you do it in a petri dish? So we can provide you with all of the testing data that you want. And by the way, every single HEPA filter that we put into our units, which the HEPA filter is the final filter, excuse me, that the units see, that anything sees in the units, every single one of them has been certified. It's been challenged with hundreds of thousands of particles with the spectrometer to make sure no particles make it through, right? So every single unit, every peak, every apex, anything you get from us has been particle tested. It's been particle tested, and it's been proven to be 99.99% retention at 0.3 micron. And by the way, we say 0.3, that's what Institute of Environmental Sciences makes us do, because that's the most penetrating particle size. The HEPA filters we use, they entrap everything all the way down to 0.01, I assure you, right? So the 0.3 is just what we measure at. So anyway, any testing data you guys want, we can provide. We can provide books of it, right? Bioaerosol, certification documents for the HEPA filters, anything like that, right? And keep in mind, it's not just the efficiency of the units themselves, but it's the flow rate, it's the velocity, it's the effects on the room airflow dynamics, right? That's just as important. So, I think that's a good question. First, let me establish a baseline. So the HEPA filters that we use, all the filters we use, pre-filters and the HEPA filters, all commercial grade filters, and are provided by the same vendors, that have provided HEPA filters to Intel and Samsung, Global Foundries, Micron, all the leading semiconductor companies, right? So it's the same products. And then I'm sure you guys know about the fans that we use, the EC fans. They're the most efficient fans that in the world, right? So the difference between a clean room that we fabricate semiconductors in, or that we do bio research in, and a classroom is that in the clean rooms, we have 100% HEPA filtered ceilings, right? So it's all HEPA filtered. So, and we have raised floor, so you have vertical laminar airflow coming down all the time, and so that sweeps the particles out, right? So in our case, if we did that in the schools, then that would basically, you'd have vertical laminar airflow, which would wash all the respiratory aerosols straight down, right? Now then, in the classroom, keep in mind that the occupants of the classroom are the primary particle generators, right? there, you know, we can do what's interesting and kind of fun to do too, is take an aerosol spectrometer with the scan wand on it, you know, that we use to scan HEPA filters. And if we have it adjacent to a HEPA filter, it's all zeros, right? All zeros across the readings. And we typically read 0.1, 0.2, 0.3, 0.5, 0.701 micron particles. And so when you see it in front, when you look at the readout, when the scanner is placed in front of a HEPA filter, it's all zeros, straight across the board, all zeros. As soon as you put it in room air, zoom, it shoots up by hundreds of thousands, right? And then even in a clean room, if you hold it, you know, the foot away, and then you cough, you can see the same thing. You know, the ramp up and particle concentration caused by, you know, your respiratory effluence, you know, when that occurs. But Steve, I don't know if that answers your question, but the HEPA filters are the same. The volume, you know, our units have to be more compact. I mean, we don't have the luxury of having 100% of the ceiling HEPA filtered, so we gotta pack more volume and airflow into our units. So, like the peak units, for example, they have a 6-inch deep pleated HEPA filter. So, what that means is if you stretch that out, it becomes a very large surface area, right? Mm-hmm. And then we use DEC fans that give us a lot more power than what we would normally use in a fan filter unit in a clean room, for example, right? So the you know, maybe an answer to your question is our units are, you know, on a size by size more powerful than the fan filter units that we use in clean rooms, but because the primary particle generators in the room are going to be the students. So you'll never see a class 1 reading in a classroom, right? You know, with respect to what you just said. First, you know, on the consideration of increasing what we call makeup air, you know, outside makeup air. All that does really, all increasing out, the only thing increasing outside makeup air is to provide you some dilution, some additional dilution. The more effective thing to do would be to run your fans full time, not on auto, but turn the fans on full time, because the ventilation rate or the circulation rate, provided that you have efficient filters that can take the stuff out, is more bang for your buck than just increasing makeup air. One of the challenges with increasing makeup air is the HVAC systems don't have the cooling or heating capacity to cope with that. So, for example, we were at a school here a couple of weeks ago in North Carolina. Yeah, got to think of which Carolina I was in, right? Anyway, in North Carolina, and it was humid as could be in this school because, you know, it was a hot day, a hot, humid day outside, and so now, you know, humidity is terrible. There's dehumidifiers everywhere there, and it's all because they did exactly that. You know, they got maximum makeup air. They opened up their vents, and so then they got maximum makeup air, and their HVAC can't condense all the water vapor coming in from outside, right? So, you know, I would caution people about that. I understand CDC said to do that, but again, CDC and these guys, they're the same guys that just give us engineering guidelines. Here's some guidelines. Yeah, is it going to help? Yeah, it's going to help, but it's not going to be efficient help, you know? So that's one thing. And then the second thing, which I think is very tangible to this meeting and very important for your schools going forward, is I don't know if these guys have talked to you, but we provide engineered plans for each school. So, you know, we look at the schools, we look at the floor plan of the schools, and we say, you know, put this unit here, this unit here, this unit here, and, you know, it's all based on increasing ventilation rates without bringing in additional makeup air, right? So from an operational cost standpoint, you know, putting air purifiers in, people say, well, you got to plug them in, they got to run a motor that's going that's going to increase our electric bill? Probably not. It's probably going to decrease your electric bill because now you don't have to run an inefficient HVAC air handler motor as much as you do, right? But more importantly, you get a plan that's based on ASHRAE standards, whereby we double the ventilation rate in a classroom, and we do it dynamically, and so we know we get a displacement, a dilution, and a removal. So when you go back to your janitor, you know, what he's talking about is just a dilution. So you get an incremental additional amount of dilution, but it's at a very big cost because now you got to heat all that incoming air. And so what we're talking about is not just dilution, but displacement, because we got the dynamics in the room. So you got displacement, you have dilution, but then you also have removal, which is very important to prevent migration as well, right? But you know, your schools get a plan. So your school, the administrators of the school, and I'm pretty sure this is going to happen in the future when they come to your school and say, okay, let me see your plan. You know, what's your plan to keep the school kids and the teachers safe from pathogens and that sort of thing? And you're able to submit a plan, or you're able to give them a plan that's based on existing standards, on standards, but it exceeds existing standards, and it's all the calculations are there, all the standard references are there, IEST, ASME, ASHRAE, everything is there. So they have, I think that's as valuable as anything, is that they're not just sold, hey, here's a purifier, put it in your room, turn it on. Well, how does it feel? Does it feel better? Well, I don't know. It's more like, hey, here, we're going to give you a purifier. We're going to tell you where to place it. We're going to tell you whether to put a vertical or a 40 foot on it, and we're going to give you a plan that proves that you're more than doubling the ventilation rate in this room, and you're having a dynamic effect on the breathing zone. And so that's as much as anybody can do. Nobody can do any more than that, right? That's it. And so if I was going to a PTA meeting, if I were going to, if the governor was calling me and putting me on the carpet, hey, tell me what you're doing at your schools, to get these kids back in here and keep them safe, I give them that plan. Here's the plan. It's an engineered document. It's based on building codes, and it's very comprehensive. And no other school, nobody else has a better plan than this. And then when you start monitoring CO2, which, we can help you out there as well, right? It's inexpensive. CO2 monitors, I don't know. If Adam were here, he could tell you. I think they're $300, and it costs maybe $30 a month to monitor, right? And then, well, how do you know our kids are safe? How do you know this is keeping everybody safe? Because we're monitoring respiratory aerosols using CO2 as a proxy. We alert when it exceeds 1,000 ppm in the classroom, and we evacuate when it gets to 2,000 ppm. And I think they're going to say, wow, okay, I'm very comfortable with my kids coming back to school now, right? So it's more than just a feel-good thing. Hey, we're going to put this thing in there, and you can see it, and so you feel good. It's more than just that. It's a plan. Hey, here's a comprehensive engineered plan, and we're going. So we're not just addressing pathogens here, but we're addressing every type of pathogen, right? And the primary considerations are the viral pathogens, whether it's flu, cold, COVID, or any other virus that we're going to encounter in the future. But you're also eliminating all the allergens and other things that would be in the air, right? I think what Ray was looking for, and what he's looking for now is, how do I quantify? How do I quantify or prove the effectiveness of the unit, right? And how do I justify any spend that I do with respect to your stuff? And my reply would be, it's all quantifiable. It's all modeled with computational fluid dynamics. It's all engineered stuff, right? We're not selling a product. We're not selling a device you put in there and you plug in for people to see and feel comfortable with. We're selling want a comprehensive solution. I think we're a very competent and trustworthy entity. I think that's what you would be looking for, Ray and Andrew, is an organization that you can trust, both their integrity and their technical competence. And you put your trust in us, and you don't have to worry about school indoor air quality, COVID, or anything. I mean, we're going to give you the best solution that's available, right? And really even the cost consideration, I think it's very inexpensive compared to alternatives, right? I mean, starting to replace HVAC systems, that's a costly endeavor and a very disruptive endeavor, right?